Hi everyone, I am Dr. J. Suresh Goud, Associate Professor in Department of Mathematics, Institute of Aeronautical Engineering. Today, we are going to discuss the test of hypothesis for small samples. In this topic, we are going to discuss t-test for difference of means. See, in the previous session, we discussed t-test for single mean. Now we are going to discuss about t-test for difference of means. Suppose if I take a population with the mean mu and variance sigma square. This is a population having mean and variance mu and sigma square. If we choose two samples from this population with the sizes n1 and n2, the first sample size n1 and second sample size n2, their mean x bar, the mean of the sample is denoted by x bar, but we have two means here, that's why x1 bar and x2 bar, and their variances are s square. Two samples are there, therefore the first sample variance is s1 square and second sample square is s2 square. These two samples are drawn from the population with the mean mu and sigma square. Then the test statistic t in t-test for difference of means is x1 bar minus x2 bar by s into under root of 1 by n1 plus 1 by n2. In this formula, we know that x1 bar and x2 bar from the given data, and n1 and n2 also we know that the sizes of the two samples, but we don't know s value. This s value we can find out by using two other formulas. We know that s1 square and s2 square values. From that we can find out s square by using the formula 1 by n1 plus n2 minus 2 into n1 s1 square plus n2 s2 square. You know all the values of s1 square, s2 square, n1 and n2. From this we can find out s square. After getting s square, if you do it square root, we'll get the value of s. This else we are going to replace in the test statistic formula. Sometimes we may not know the s1 square and s2 square variances of two samples also. In that case, we can use another formula to find out s square, which is 1 by n1 plus n2 minus 2 into the first one, sigma I equal to 1 to n xi minus x1 bar whole square. That means sum of squares of deviations from the first sample mean plus sigma I equal to 1 to n xi minus x2 bar whole square. That means sum of squares of deviations from the second sample mean. By using this formula also we can calculate s square. After getting s square, by taking under root, we'll get s value. So now this is the tabulated value modulus of t, test statistic t value, and t alpha by 2 tabulated value we can choose from the t distribution table with n1 plus n2 minus 2 degrees of freedom. The symbol of degrees of freedom is nu, which is defined as in this t-test n1 plus n2 minus 2 degrees of freedom. We can choose this value from the table, and t value we can calculate from the test statistic. After getting t, you can take modulus of t. If t less than t alpha by 2 less than mod t, we can accept h naught. Otherwise, we can reject h naught. H naught means null hypothesis. Suppose the first problem in this case, the means of two random samples of sizes 9 and 7. See, in this problem clearly given that two random samples of sizes 9 and 7. That means the first sample size n1 which is 9 and the second sample size n2 which is 7. Their means are also given. The first sample mean 196.42, which is denoted by x1 bar, and the second sample mean also given, which is 198.82, this is x2 bar, and also given the sum of squares of deviations from their respective means are 26.94 and 18.73. The sum of squares of deviation from the first mean is 26.94, like that from the second mean 18.73. So these data is given. Now what is the problem? Can the samples be considered to have been same populations? That means these two samples of sizes 9 and 7 have been drawn from the same population or not, we are going to verify. According to the given data, the sample sizes are 9 and 7. That means they are small samples. Small samples and the means are given. That's why we can use t-test for difference of means. What is t-test for difference of means formula? T equal to x1 bar minus x2 bar by s into under root of 1 by n1 plus 1 by n2. Here all values we know that except this s value. We can find out s value by using the s square equal to sigma xi minus x1 bar whole square plus sigma xi minus x2 bar whole square by n1 plus n2 minus 2. If we simplify this value, we are going to get 3.26, which is s square. From this, we can find out s value by under root of 3.26, which is 1.81. Now, the test of hypothesis process that we have discussed earlier, we have totally 5 steps. What is step 1? Null hypothesis. We are going to define or set up null hypothesis. How to set up null hypothesis? We need to assume that there is no difference between the means of two samples. That means the first sample mean and second sample mean we are going to take as equal. That is x1 bar equal to x2 bar. And in step 2, we can set up alternative hypothesis that is denoted by h1. This is completely against to null hypothesis. That means x1 bar not equal to x2 bar. Step 3, we are going to define level of significance not given in the problem. You can take general level of significance, which is 0.05. Now we can choose T alpha by 2 at n1 plus n2 minus 2 degrees of freedom from the T distribution table. T alpha by 2 means where alpha equal to 0.05 by 2 means 0.025 at 14 degrees of freedom. This value we can choose from T distribution table, that is 2.15. So the tabulated value we got it in step 3. Now we can find out the calculated value, which is test statistic T, by using the formula x1 bar minus x2 bar by s into under root of 1 by n1 plus 1 by n. This s value we calculated already, which is 1.81. And x1 bar 196.42 minus x2 bar also given 198.82. By s into s we calculated, which is 1.81, under root of 1 by n1, first sample size 9 plus 1 by n2, second sample size 7. If we simplify, we'll get minus 2.63. So T value minus 2.63. Therefore, modulus of T you take plus 2.63. And you compare the T alpha by 2 value and mod T. So mod T is greater than T alpha by 2. That means we are going to reject null hypothesis. That means there is a difference between the means of the given two samples. Similarly, if we consider another problem, samples of 2 electric light bulbs were tested for length of life and following data were obtained. So 2 electric light bulbs are given, type 1, type 2, 2 different types. The first type sample 8, second type sample size is 7. And the first type sample mean is 1234 hours and the second sample mean is 1036 hours. And the first sample standard deviation is 36 hours and second sample standard deviation is 40 hours. Now test whether there is any significant difference between two sample means. Now we need to decide which test is suitable by using the given data. If you observe in this problem, the sample sizes are 8 and 7. That means they are small samples. And two different samples are given. So we are going to identify this problem is suitable for t-test for difference of means only. Now, in this case, we need to find out S square value. Because S1 and S2 values are given, we can use this formula 1 by N1 plus N2 minus 2 into N1 S1 square plus N2 S2 square. So from this S square equal to 1 by 8 plus 7 minus 2, 8 into S1 square 36 square plus S2 square 40 square. We simplify, we'll get S value 40.73. Now we are going to follow the test of hypothesis procedure. We are going to set up null hypothesis H0. That means there is no difference between the two sample means. And alternative hypothesis, there is a difference between two means of the samples. And alpha value not given, we can take general alpha value 0.05. From this we can find out T alpha by 2 at 13 degrees of freedom because N1 plus N2 minus 2, where N1 equal to 8, N2 equal to 7. 8 plus 7 minus 2. 13 degrees of freedom is 2.16. Now you substitute this test statistic T formula x1 bar minus x2 bar by S into under root of 1 by N1 plus N2. If we simplify, we'll get mod T equal to 9.39. In the previous slide, T alpha by 2 value 2.16 and mod T is 9.39. So mod T is greater than T alpha by 2. We are rejecting the null hypothesis. That means there is a difference. We are rejecting null hypothesis. Actually, what is null hypothesis? There is no difference. But we are rejecting the conclusion. That's why there is a difference between the means of the two samples. Now, similarly, third problem, two independent samples of 8 and 7 items. The first sample size is 8. Second sample size is 7. Add the following values. Now again we are going to check is there any difference between the means. But here, compared to the previous problems, only x1 and x2 values are given. Even the means are also not given. We need to find out x1 bar and x2 bar by using the average. Similarly, you can find out the sum of squares of deviations from the first mean. Similarly, sum of squares of the deviation from second mean. So we'll get 26 and 16. We can find out S square value and S value 3.23. Similarly, we can set up the null hypothesis H0, H1 and alpha 0.05 at 13 degrees of freedom 2.16, which is tabulated value. And the test statistic T equal to x1 bar minus x2 bar by S into under root of 1 by N1 plus N2. All values if you substitute, we are going to get T equal to 2.15. But you take mod T which is also 2.15. And in this case, mod T, we got it less than T alpha by 2. That means we accept null hypothesis. Accepting null hypothesis means there is no difference between the means of the given samples. Okay. These are the exercise problems on this topic. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.